Right now, as you watch this video, you are walking through a battlefield. There are more microscopic entities on Earth than there are stars in the observable universe. Most of them ignore you. Some actively help you, but right now, a tiny, silent invader could be floating toward you. It doesn't eat. It doesn't breathe. It can't even move on its own. By all traditional definitions of biology, it isn't even alive. Yet this non-living piece of cosmic dust has a single, terrifying capability. It can break into your cells, rewrite your DNA, and turn your own body into an automated factory for its own duplication. It's a virus, and for billions of years, a brutal, microscopic war has been raging inside every living thing. But humans did something incredible. We invented a way to give our bodies the ultimate cheat code to win the war before the first shot is even fired. Today, we're going inside the microscopic battlefield to see exactly how viruses hijack your body and how vaccines pull off the ultimate biological trick to stop them. To fight an enemy, you have to understand what it is. And honestly, a virus is embarrassingly simple. If a bacteria is like a fully functioning independent house with its own plumbing, electricity, and ability to grow, a virus is literally just a stray piece of paper with a recipe printed on it. Specifically, it has two parts. Inside, you have a strand of genetic code, either DNA or RNA. This is just a flash drive filled with a single set of instructions: how to build more viruses. On the outside, it has a protective protein shell, often covered in little bumps called spike proteins. Because it's just a flash drive, it can't do anything on its own. It's completely passive. If you leave a virus on a plastic table, it will sit there forever until it degrades. It can't reproduce. To come alive, it needs a host. It needs you. When a virus enters your body, say, through a droplet you inhaled, it goes hunting. But it can't just walk into any cell. It has to play a game of biological lock and key. The spike proteins on the virus act like a master key. Your cells have receptors on the outside that act like locks. If the virus's key fits your cell's lock, the cell opens the door. It thinks the virus is a friendly nutrient. Big mistake. Once inside, the virus cracks open and inserts its genetic flash drive right into your cell's manufacturing machinery. Your cell doesn't know any better. It blindly reads the instructions and stops doing its normal job. It becomes an automated virus factory. It manufactures thousands of viral shells. It copies the viral code. Eventually, the cell is entirely consumed and bursts open, releasing an army of thousands of new clones into your tissue, ready to repeat the process. This cellular destruction is why you start feeling sick. But your body isn't a helpless victim. It has a multi-layered military defense force, your immune system. And when a cell bursts, the alarms go off. Phase 1 is the innate immune system, your first responders. They see the chaos, rush to the scene, and start fighting blindly. They release chemicals that cause inflammation and raise your body temperature. Yes, a fever isn't the virus hurting you. A fever is your body turning up the thermostat to cook the virus and slow down its factory production. But if the first responders get overwhelmed, they call in the special forces, the adaptive immune system. The first responders bring a piece of the dead invader to your B cells. Think of B cells as elite weapon engineers. They study the virus's spike protein key, and they design a perfect counterweapon called an antibody. Antibodies are like custom handcuffs. They clamp onto the virus's keys, making it impossible for them to unlock your cells. They also glue the viruses together, making them easy targets for cleanup. Meanwhile, T cells patrol the area like precision soldiers, identifying cells that are already hijacked and safely destroying them to shut down the factories. Once the war is won, your body keeps a few memory cells in reserve. They remember the exact blueprint of that virus. If that same virus ever shows its face again, the memory cells instantly deploy the antibodies. You wipe out the invader before you even realize you were exposed. You are now immune. Naturally gaining immunity has a major flaw. You have to get dangerously sick first. Some viruses can cause permanent damage or even defeat your immune system entirely on the first try. This is where vaccines come in. A vaccine is essentially a wanted poster for your immune system. Instead of sending a live, fully armed enemy army into your body, a vaccine introduces a completely harmless, broken, or deactivated version of the virus. It can't replicate, it can't hijack your cells, and it can't make you sick. But your immune system doesn't care if it's a drill. Your B cells inspect the harmless vaccine components, say, "Aha, an invader," and take their time building perfect antibodies and creating memory cells. It's a completely safe practice run. So, when the real, dangerous virus actually enters your body months or years later, your immune system doesn't waste days trying to figure out a weapon. It pulls out the wanted poster, recognizes the enemy instantly, and unleashes its pre-made arsenal to wipe it out in hours. Think about how mind-blowing that is. Vaccines are the ultimate bridge between human intelligence and natural biology. We use our understanding of code, chemistry, and medicine to train our internal defense forces against threats they've never even seen. Because of this, diseases that used to devastate entire civilizations have been completely eradicated or minimized to a minor nuisance. The next time you hear about a virus or a vaccine, remember, it's not just medicine. It's an incredible microscopic blueprint designed to keep the defense force inside you one step ahead of the smartest hitchhikers in the universe. If you found this breakdown helpful and want to see more deep dives into the hidden world around us, hit that subscribe button, leave a comment below with what we should explore next, and we'll see you in the next video.